Guys, I would like to take you one of the question in A levels about electromagnetic induction, and you realize that we are having a disk that is rotating in a magnetic field. Then the question is, define electromagnetic induction. Define electromagnetic. What is electromagnetic induction? Electromagnetic induction is a process through which a current is generated when a conductor cuts through a magnetic field. So in this question here, we are told, our candidates were told to define magnetic flux. So the candidate who was to get this mark was to define this as the product of magnetic flux density and the perpendicular area to the magnetic field, because we understand that from our previous discussion, we say that magnetic flux is equals to the magnetic flux density times the area, and the area we are talking about is the area that is perpendicular to the magnetic field, right? Then now in this particular question, what were the candidates supposed to address here? Calculate the magnetic flux through the disk. First, we need to know the area, and the area that we were to work out is this area that I've tried to shade red. Then the area will be obtained from the radius that was provided, but this question the radius was 0.36, so we're supposed to find the area pi r squared, and then we apply this particular formula, and then we were to get 6.9 times 10 raised to power -3 Weber. Then the next question that was quite interesting also was to calculate the magnitude of electromotive force, induced electromotive force. Induced EMF is equal to the rate of change of the magnetic flux linkage. And then if you work it out, first we were to find the period, and the period was that, and then since we had gotten the magnetic flux from this particular end, we could divide by the period to get the rate of change, and that's going to be equivalent to 1.7 volts. So guys, the EMF is equal to the rate of change of magnetic flux linkage. Then we are supposed to describe whether the current was going to flow from the axial to the disk or from the disk to the axial. So something that we ought to remember here is that according to Lenz's law, the induced EMF here will be in such a way it opposes the rotation of the disk, and the force will be downward. The induced EMF will produce a downward force.